Good morning. Myself, Dr. Kiran, presented here the research entitled Screening of a National Product for Efflux Pump Inhibition to Treat the Antibiotic Resistance Factor. As we know that the antimicrobial resistance is recognized as one of the extreme risks to the human health. The overprescribing and improper use of antibiotics leads to the emergence of this type of the resistance. In recent time, the increasing the emergence of beta lactam resistance is a very bigger challenge because they to treat the infections caused by the resistance pathogen. Hence, the present study is focused on the screening of antibacterial agents which will be previously isolated from the plant and microbial source like curcumin, flavonoids, different bacterial pigment to treat the multi-drug resistant bacteria as an efflux pump beneficiary. To achieve our goal, we set some objectives like first we screen the antibacterial activity of naturally occurring plant and microbial compounds for efflux pump inhibition in MDR strain. Then we carried out the synthesis of the bioconjugates of these naturally occurring metabolites with standard antibiotic, and then we tested the efficacy of synthesized bioconjugates against the local pathogenic isolates. This is the graphical abstract of my present study. To achieve this objective, we used the following methodology like we used bacterial pigment produced in orange pigment from streptomyces, narangenin, curcumin, blue pigment for the screening purpose. The screening of efflux pump inhibition was carried out by using the ETBR cartwheel assay. Then the bioconjugation will be carried out by simple method with the standard antibiotic like penicillin and ciprofloxacin, and also we screen the efficacy of all the synthesized bioconjugated system against the MDR strains, which will be isolated, which is the local isolation, also some standard strains we use for. And then we also carried out the study of conjugates, characterization of these synthesized conjugates by using different analytical tools. Okay, the results of our present study: first we carried out the presence. First we screen the microorganisms like S. aureus and Pseudomonas aeruginosa for presence of the active efflux pumps. For this purpose, again, ETBR cartwheel assay is used. We can see here that the strain where there is an presence of the active efflux pump, there is no show the fluorescence, means efflux activity of in the fluoro where the organism we shows the efflux we shows the fluorescence which indicates that there is a no efflux pump is activated, active efflux pump is present, no active efflux pump is present in that organism. But you can see here S. aureus ATCC 6538 strain, there is no fluorescence is observed which indicates the presence of a active efflux pump, and hence this strain we select for the further study. Then we also screen these organisms for inhibition of the efflux pump. For this purpose, we use different natural products like curcumin, proteasin, blue pigment to check the activity of this natural product for inhibition of the efflux pump. Again, we can say that there is an curcumin and blue pigment have highest activity to inhibit the efflux pump, though again there is a no fluorescence is observed. The fluorescence is observed when these S. aureus treated with this natural product. You can see here the Staphylococcus aureus where in the control study there is no fluorescence, but when it treated with the curcumin and blue pigment there is an increase in fluorescence. Then again we carried out the we select these two, blue pigment and curcumin, which is a positive for inhibition of the efflux pump, and then we carried out the experiment with the standard. You can see here there is a growth control, then only the organism, that is S. aureus, treated with the ETBR. Then we use the positive control piperine, which is again efflux pump inhibitor, and our isolated compounds, that is blue pigment and curcumin. As compared to the control and ETBR treated, there is increase in the fluorescence in case of the blue pigment and curcumin, which is compared with the positive positive control, that is piperine. Piperine is inhibitor of efflux pump, and also the fluorescence intensity was measured. You can see here in blue pigment and curcumin, the fluorescence intensity is highest as compared to the piperine, which is a positive control. Hence, from this data, we confirm that the curcumin and blue pigment inhibits the efflux pump. Then we used to study the conjugation study, that we used these pigments and with a standard antibiotic. The pigment curcumin with a standard antibiotic show the increase in an inhibition of staphylococcus. In case of the staphylococcus, there is an inhibition in a conjugated, means on the basis of zone of inhibition we carried out the fold increase in antibacterial activity, and we can see here in producing the, and in naringenin there is an increase in about 1.9 fold of the antibacterial activity. Similarly, in case of the pseudomonas, there is an increase in about 1.5 to 1.2 fold increase in antibacterial activity. Then again, we carried out the characterization of the synthesized bioconjugates, and you can see here there is an curcumin penicillin conjugates. There is this is the peak which show both standard peaks of the curcumin also and also the penicillin. Means this spectrophotometric analysis also confirm the synthesis of the bioconjugate with the standard antibiotics. So from this study we conclude that the natural product producing an orange pigment from streptomyces will increase the antibacterial activity by 1.2 fold. Then spectrophotometric analysis also confirms the synthesis of bioconjugates natural product. ETBR cartwheel assay confirms the presence of active flux which we active flux pump which will be inhibited by natural products, and this is a new strategy to combat the multi-drug resistant bacteria which is the need of our. Thank you. These are the references.